All right, so first off, when you look at numbers 1 through 5 on your worksheet, let's just look at the instructions. That way I can tell you what we need to cover. It says write each polynomial in standard form, then classify it by degree and number of terms. Okay, so that's what it says in the worksheet. So first off, let's talk about standard form. So standard form of a polynomial. Now, the standard form of a polynomial, I'm going to try to write it in a simple way, okay? I can write it in a very general form, and it looks really weird and complicated. So I'm going to try to write it in a simpler way, okay? So your standard form normally looks something like this. I'm going to put ax to the 5th plus bx to the 4th plus cx to the 3rd plus dx squared plus ex plus f. Now, this is in no way the standard form, okay? But this is an example of what standard form looks like, okay? Notice how the powers start from the highest power and they start counting down, right? 5, 4, 3, 2, 1 is x to the first, but we don't write that. And then x to the 0 disappears, right? Because x to the 0 is a 1, so that's why it's just f. All right, so it counts down. So whenever you write things in standard form, you write them in descending order. So notice how, where is it at? I'm trying to find out where they said that. But well, maybe they don't say it here, but they'll tell you that the standard form should be in descending order from highest to lowest. Okay, so let me write that down for you guys. Descending order. This is from highest to lowest. From highest power to lowest power. Okay, and then there's ascending order, which usually isn't used, but it's a possibility. It is from lowest to highest. So from lowest power to highest power. And if there's a power that's missing, so let's say it goes 5, 4, 2, and then that's it, that's fine, as long as it's from high to low, or low to high, depending on what they want you to do. If you've ever flown in an airplane, you'll notice that when they take off, they don't say we're about to take off, they'll say we're going to ascend to a certain amount of feet, where they don't say we're going to fly straight up or anything, right? They'll say ready for takeoff, and then say we're going to ascend to a height of 5,000 feet. And then when the seatbelt thing comes back, when you're about to land, they say we're going to start our descent, right? They're going from high to low, right? They're going from the sky to the ground. So they say we're going to start our descent, okay? So it's going down from high to low. So standard form of a polynomial, again, this is not the standard form. I want to repeat that again. This is just an example of what it looks like, okay? It's written in powers from high to low, and kind of putting them in order. That's the main thing they want you to do for the polynomials in standard form. Now, they also want you to classify it by degree. So let me talk about the names of the powers by degree. So if you see a power of 2, okay, a power of 2, we call it I guess you could call it a square, right? Some people like to say power of 2, but most people call it a square. So it's a square polynomial or square polynomial, okay? Some people will call it quadratic. Now, if it's a power of 3, we call it a cubic. Okay, a power of 4, quartic. A power of 5 will be quintic. And after that, usually we don't even mention quintic. We'll say power of 5, okay? But usually, at the most, they'll mention the 5th power. And after that, they'll just say, okay, it's a polynomial of degree 6, of degree 8, of degree 2, okay? Or a cubic degree, quartic degree, quintic degree, okay? So you'll notice in the instructions they say classify it by degree. In other words, tell them what it is. Is it a quadratic? In other words, a square power, right? Is it a cubic, a quartic, a quintic, a sixth power polynomial? And then they say, and by the number of terms. So when you classify something by the number of terms, that's pretty easy. I don't even have to write this down. If it has 6 terms, you say that it's a 6-term polynomial, right? If it has 3 things in it, it's a 3-term polynomial. Okay, so just to help you out, let's look at number 2 really quick, and then we'll move on. So number 2, it starts off as 8 minus x to the 5th plus 9x squared minus 2x. Now they say write the very first part of the instructions, say write each polynomial in standard form. So here we go. Standard form looks like this: negative x to the 5th plus 9x squared minus 2x plus 8. Notice I wrote it from highest to lowest. Okay, highest power to lowest power. So that's part of my answer. Okay, the next part of the answer says classify it by degree. Well, the highest power is 5. So this is a quintic polynomial. Okay, and then they say by the number of terms. Well, it has 4 terms, so I'm going to write with 4 terms. And that's my answer to that problem. Notice I didn't really have to do much math, right? I didn't have to do any type of calculations, maybe some rewriting, but I just rewrote the function, or the expression in this case. I rewrote the expression, and then I classified it by its degree, and then by the number of terms. So that's pretty easy, right? It doesn't take a lot of like brain power to do that. It's just organize them, give it its name, and there you go. By the way, sometimes you'll hear them say name the polynomial. I don't know if you guys have ever seen those memes online with like they'll say like funny math answers or test answers. Sometimes people say this polynomial's name is Bob. Right? That's not what we mean. Naming it means tell it the degree. Is it a quadratic, a cubic, a quartic, a quintic, a 6th power, right? So don't ever name it with an actual name. You will get it wrong. But I have seen those. Those are pretty interesting to see on those Twitter feeds or whatever those guys are, the handles. So anyway, now end behavior 6 through basically 17. Okay, 6 through 17 is basically this next part. And this is going to be a lot of writing right now, okay? So I do apologize in advance for it, but it is necessary for you guys to know this. So end behavior of a function. Now first, we're going to assume that the function is in standard form. Because if you don't put in standard form, then all of your answers are probably going to come out wrong. Okay? So the first thing you got to do is write it in the correct manner. Okay? So let me write the following down. Ax to the n plus bx to the n minus 1 plus etc. Okay, the only thing that we have to worry about is the a term and the power. Okay, those are the only things you really have to focus on. So once you write it in standard form, look at the very first coefficient and the first power. Okay, I don't care about the rest of it. Bx to the whatever, cx to the whatever. Who cares about that stuff, okay? Just the first term in your polynomial. Okay? So here we go. Here's the part that, like I said, you have a lot to write with. If n is positive. So in other words, if the power is a 2, a 4, a 6, an 8, a 10, a 12, okay, if n is positive. If n is positive, then the graph either opens up on the left side and up on the right side. So on the left side it goes up, on the right side it goes up, if A is positive. Okay? Or, by the way, don't get scared by the graphs that I'm drawing. Okay? The stuff in between can look however. But very important that we notice that if A is positive and N is positive, then the graph will start on the top left and it'll end on the top right. Whatever it does in the middle, going up and down, who cares? But the end behavior on the left side will be going up, on the right side will be going up if your power is positive and your coefficient is positive. Okay? But if your power is positive and your coefficient is negative, then it flips it upside down. And they both go in the downward direction. So if A is negative, your graph kind of looks similar to that. I mean, guys, it can look like this. It can look like that. I don't know. Whatever. But notice down, down. Okay? So if A is positive, let me write down what you should put. It goes up to the left, up to the right. Okay? So that's what you're supposed to write in that situation. If A is negative and your power, your highest degree, is positive, then it's going to go down to the left and down to the right. So if anything, you might want to write yourself a little hint and say, if the highest power is positive, then it either both goes up or both goes down. Okay, they both do the same thing, up, up, or down, down. Okay? Again, whatever happens in between, who cares right now? Okay, we're just thinking about the end behavior. What does it do at the end points? Okay, so it's going to go up to the left and up to the right, or down to the left, down to the right. That is basically all you have to write for 6 to 14, but there's still more, by the way. We're not done with this definition because we only defined it if n was positive, but what if it's negative? This is what I was telling you about, like, there's a lot to define, but it's easy because you don't have to do any work. You just have to look and say, oh, odd power, A is positive, so it does the following, right? You just kind of have to match it. So, if n is, oh my gosh, I just realized there was something wrong. Not a lot. Do me a favor, guys. I just realized I wrote something wrong. If n is positive, should not say positive. I'm sorry, it should say even. Even. Let me write it in a different color. I apologize for that. Even. Okay, I know. I'm sorry. Are you writing it in pen? Yeah, I know. I have a student of mine. Anybody know Renee Del Valle? Yeah, she writes really nice. Her notes are like perfect. She even does like that whole, you know, when you write a letter and then she'll come back and like shade it in and do all that crazy nice calligraphy look stuff. Every time I make a mistake, you hear her go, oh, and I'm like, sorry, Renee, because all her notes look so nice, and then she's like, now I gotta erase it, and she can't, right? And I told her, you could buy erasable pens, and she's like, yeah, but they don't look nice, they don't write the same. So yeah, I apologize. N has to be even. Okay, I'm sorry. N has to be even. And then N has to be odd. So if N is odd, you get the following. Okay, the graph might look like this, or it might look like this. Now, not specifically like that, but again, the N behaviors, okay? So if A is positive, it's going to go from the bottom left to the top right. So bottom left to the top right. That's the end behavior. It starts at the bottom left, and then it does whatever it has to do, and then it goes to the top right, okay? So bottom left, top right. If A is negative, then it starts at the top left to the bottom right. And that's that big old definition I told you guys about, okay? So when you do these problems from 6 to 17, you got to ask yourself, the very first thing you're going to do is it in standard form? And if it is, which not all of them are, okay, but if it is, then you're going to say, okay, the highest power, is it even or is it odd? Because if it's even, then you look at this definition right there. But if it's odd, you go to this definition right there. After you figure out if it's even or odd, the highest power, then you look at the number in front of that variable. And if it's a positive number, then you're going to say, okay, well, if it's odd and positive, then I'm going to do that side. So it's bottom left to the top right. If it's a negative A term, then it's top left to the bottom right. Okay, so you just got to start picking. You're going to basically say, like, I'm doing this, and then this is what I have, so this is my answer. No math required. Okay, that's what's nice about these lessons, is that there's no math required, but there's a lot of definition required. Okay, you got to look through your definition. So let's look at number 6. Let's do one that's kind of easy, and then we'll go to one that we got to move around. Okay, so let's look at number 6. So number 6 is y equal to 5x cubed minus 2x squared plus 1. You should notice that number 6 is already in a standard form. What is the highest power on it? A 3. And 3 is even or odd? Odd. So I'm going to go back to my notes and I'm going to say, okay, odd. If n is odd, okay, great. What is the A term? What's the number in front of the highest power? So what is the number in front of the power of 3? A 5, a positive 5. So if A is positive, then what should my answer be? Bottom left to the top right. So all I'm going to do is write bottom left to the top right. And that's it. That's all you have to do for these problems. Now, there is a little bit more that they want you to do. They say name the function. Again, this is the part where I don't just random names. This is a cubic function, okay? So I'm going to write cubic function, okay? Because it's a power of 3. So it is a cubic function. All right, so that's what number 6 is supposed to look like. Notice I didn't do anything really. I just kind of surveyed what they gave me and used my definition to figure it out. Okay, this is something I highly recommend you guys put on your cheat sheets. Okay, well, you don't need it for tomorrow, but when we do eventually test on something like this, I would recommend you put it, because it's something you may not remember. It's a lot of info, right? So it's good to have. Now, let's look at, I don't know, number 10. Number 10 looks like it has a lot of stuff in it. So number 10 is y equal to 8x squared. Actually, should I do number 10? Because it's going to be odd again. Let's do number 13. 13 instead. Because I don't want it to be the same answer as the one we just got. So there's number 13. So first thing I have to do is rewrite it in standard form, because it is not in standard form. It's all mixed up. I need the high powers and then counting down, right? So y equals negative 5x to the 6th minus 22x cubed plus 2x plus 15. Okay, so there it is, from high power to low power. So look at the highest power. Is it even or odd? Even. So we know it's an even power. So we're going to go to the very beginning of those definitions, right? If n is even. My a term, is it positive or negative? Negative. It's a -5, right? The number in the very front is a negative. So even power, negative coefficient. So let me go over here. Even power, negative coefficient. It's this one right here. Down to the left, down to the right. Okay? So I'm going to write that down. Down to the left, down to the right. They're going to want me to name this thing. What kind of function is it? And what's the highest power on it? 6. So they didn't give us a definition for 6, but it is a hectic. It's hectic. That's what it is. It's crazy, I guess. But it's hectic. But we're not going to write that. We're just going to put 6th power polynomial. For 7, they call it septic, which is not a nice vision, a nice thing to think of, because most people think septic tanks, right? So yeah, you don't really want to think of that. So there you go, 6 power polynomial. Now, aside from that, okay, so far you guys should be able to do 1 through 14, no problem. Turn the paper over, okay? Turn the paper over, and let's look at number 15. I'm going to do a real quick sketch of what it looks like, okay? So the graph kind of looks like this. All right, so pay close attention, guys, okay? Here we go. Determine the sign of the leading coefficient. So the leading coefficient is that number, the a term. Notice how this goes bottom left to top right. What power is it, even or odd, if it's bottom left to top right? It's odd, right? So I'm going to put n is odd. Now, since it goes bottom left to top right, what's my a term? Is it positive or negative? Again, you're looking at your definition. What was it? Positive. Okay, it's positive. They say determine the sign of the leading coefficient. It's positive. They say figure out the degree of the polynomial function. So how the heck am I going to figure out if this is I know it's odd, so but is it a 3, a 5, a 7, a 9? Like, how do I know? Because if I look at 16, I have no idea, right? So here's a little trick. So there's another little piece you're going to put in your notes. Okay, a function has one less change in direction than its power. Okay, one less change in direction than its power. Look at the picture I drew right there, the red graph. How many times does that change directions? So it's going up, and then it goes down, that's one change, and then it goes up. That's 2 changes in direction, right? So what's the power? Remember, it has one less change in directions than the power. Now the power is 3. Because the changes in direction should be 1 less. So if the power is 3, you take away one of them, you have 2 changes in direction. That's what that one is. So that's a power of 3. Okay? So I'm going to write third or cubic, I guess you can say, the degree of the function. So you're going to say degree equals 3. How many changes in direction for number 16? See, it's going down, then up, then down, then up, then down. How many times did it change direction? For number 16? So down, then up, that's 1. Then down, that's 2. Right? Let me try to draw it so you guys can see it. All right, so check this out. Down, then up. That's 1 change, right? Then down, 2. Then up, 3. Then down, 4. So if it changed direction 4 times, what's the power? 5. You add 1 more. Okay? So number 16, write that down right now. The degree is 5. What's the degree for number 17? How many times did it change direction? It goes down, then up. 1. So what's the power? 2. Okay? Now you still have to figure out for number 17, is it a even or odd power? Well, since they both go up, it would be even, right? And they ask you, what's the sign of the coefficient? Once it's going up and up, A must be positive. So these are all things you guys have to figure out by looking at your list, okay? But notice, we haven't been calculating anything. We're just looking at information and translating it into its meaning, okay? And that's why I'm telling you, a lot of people, they don't like this lesson because they're like, oh, this is so hard. And I'm like, you're not doing anything. You're just looking at information and writing down what you see, right? You got to be observant with this. Let me see. I think we're pretty much done. Let's go ahead and do like number 24, and then I think I'll stop. Okay. So let's see, number 24. Because the rest of it, you guys should know. You guys should know how to do 19 to 26 and stuff. But I think for number 24, just so you can see what to do sometimes. Okay, so we have x times 3x times x plus 2. The instructions say to classify each polynomial by degree and by number of terms. Simplify if necessary, okay? So I'm going to multiply. So x times 3x, that's 3x squared times x plus 2. And then 3x squared times x plus 2, I got to distribute, right? I'm going to distribute this in here. So I get 3x cubed plus 6x squared. So there you go. I'm done. Is this in standard form? Yeah, highest power first, the next highest power is after that. So it's descending. All right, so they say classify the polynomial by degree. So the highest power is 3, so this is a cubic polynomial. And then number of terms, it has 2 terms. So I'm going to write with 2 terms. And that's all you have to do for number 24. I mean, yeah, I did have to do a little bit of math in that one, okay? But forgive me if I make you multiply, right? It's not that bad, hopefully. Real quick, guys, number 26. What do you guys think? Is there anything that you can do to number 26? No, it's just a 5. What's the degree on it if there is no x? 0, okay, because there's no x. That means it was x to the 0, which makes the x disappear, okay? So the degree is 0, and then when they say how many terms? So you're going to say 0th degree polynomial, okay, with 1 term. If the power happens to be a 1, you say first degree, and then 2, 3, 4, 5, we talked about that, right? Squared or quadratic, cubic, quartic, quintic, etc. So hopefully you guys don't find this too difficult to do. It's probably going to be a little time consuming. I'm not going to lie to you guys about that. It takes some time to evaluate your work based on a chart of stuff that you had to write down. So it takes a little bit of time, but it's not hard work, okay? It's not that hard. I hope not. So go ahead and we do have about 13, well, am I right? 13 minutes? Yeah, 13 minutes. If you want to work on it, feel free. That way you guys can get some of this stuff out of the way. Yeah.